electronics. Okay, very interesting, this type of things. So we have to know the evolutions of the microelectronic circuits. Okay, so from earlier day to present day, how the evolution has actually come and what are the new devices, new generations have actually have come up. Then one most fundamental law in VLSI, that is Moore's law. I think all of you have heard about Moore's. Then trends in VLSI, some technical challenges also, because in any technology there is some challenges, and the job of the researcher is to take the challenge or find the scope where the researcher can contribute. That is the main challenge actually. Okay, so in any technology, nowhere it is in the world that can offer only the good thing. It cannot be possible. If there is a good side, there must be a bad side. Okay, what are the challenges? So our job is to take the challenge and to solve the problem. Then IC manufacturing. Then why VLSI? Some VLSI design flow. Then some design methodology. And what are the VLSI design tools are there? Styles, different type of approaches, and some of the brief of the MOS technology. Okay, MOS means metal offset semiconductor technology. Now you see the first computer, because the so big structures, okay, like a building. Okay, now we can see it's a 10-story, 20-story building type of thing. Okay, so this is the Babbage difference engine. You can see it took almost 25,000 parts to assemble it. Okay, so you can imagine, and cost is, this is in pounds, 17,470. So it almost, I think, the 17 lakhs type of thing. So in that day, in the year of 1932, Charles Babbage actually, he has first invented this one. So this was the first picture, the first computer. And nowadays, if you get computer, with this first computer, now everybody laughs. Okay, so what is that? What was that in the earlier days? Yes, but that is the reality. That is the reality. Okay. Now this is the picture of the first electronic computer. It came into the existence in 1946, just after the Second World War. Okay. So the ENIAC, I think the electronic numerical integrator and computing. Okay, the full form of this ENIAC. Okay, you can see. So how difficult, okay, they have to assemble all these, actually the machineries, okay, and the one man, he is actually performing some numerical calculations of that. So it dates back to 1946. Can you imagine if their infrastructure and now today's infrastructure? No, it is not possible, because now we can have this type of computer in our fingertip, in a small IC. Small IC can do the wonder. You can integrate everything on a small finger nail. Okay, but in 1946 it was not like this. So obviously there is some contribution of some beautiful researchers, pioneers, scientists. Okay, and it took long time. Okay, almost there you can that 70 years, 75 years, 80 years. Okay, to arrive at this stage, today's stage. But this effort was actually made by them, so we should not forget their effort. Because of them only, because of this invention only, now we came to the today's world. If it was not invented that time, people are not bothered. Okay, and we used to have this system till today also. Then this is the transistors, one of the revolution we can say in our electronics. The BJT, the bipolar junction transistors. In last year also, we used to celebrate 75th year of anniversary of the invention of bipolar junction transistors. 75 years back, three renowned scientists, the Shockley, Bredin and Bradin, three batchmates, okay, friends in the Bell laboratory, they have invented, okay, their device, okay, the point contact bipolar junction transistors. So in 1948. So this is the picture of that. And transistors has done actually everything in the electronics. Okay, so bipolar junction transistors, actually when the moment it was invented, it came into the market, then other technologies actually has grown. Okay. Otherwise, without this transistors technology, no nothing, MOSFET or any gate structure or any advanced technology today in ECE architecture we cannot think of. Okay, so it is actually involved in our body. Okay, so if you study about the transistors, you cannot forget. So that is the impact actually they have given to us. Okay, this is the impact of the transistors, impact of the bipolar junction technology. Then first integrated circuits, there is a picture you can see how earlier it was, 1960s, bipolar logic, and then in Motorola they have come up with their technology in 1966. ECE 3-input gate, that is intercoupled logic. Okay, this was the first integrated circuit. So this is some kind of history actually, because I told you, because history is very very important, because the future is based on history. If you do not know our history, okay, if you do not know our culture, then how can we give to our new generation? So we must know the history, we must know our background, we must know the history. Okay, because always future builds on the, depends on the history. Without history, nothing will happen. Now the evolution of microelectronics, you see, from 1948 to 1980 there is a big journey. In 1948, the first transistors came, only one single transistor. Okay, now 1961, this is called SSI, that means small scale integration. It actually comprises of almost 100 these transistors. Okay, and some gates, flip-flops was actually the concept. Okay, it was designed with this 100 of number of transistors. Then in 1966, after 5 years, then this integration, this was called MSI, medium scale integration, where number of transistors are also rapidly increasing. From 100 to 1000, 10 times transistors, it will increase. Okay, it was increasing the MSI. And from this technology, we could be able to design some counters, marks, and adder circuit. Now, whatever you are reading in your books, okay, the digital technology, digital electronics. Now, after 5 years again, there is a LSI, large scale integration. Then again, the 10 times increase. Okay, from 1000 to it is a 20,000. So 20 times. 20 times increasing in the transistors. Okay. In LSI, we can design that up to 8-bit microprocessor, ROM, RAM, okay, this type of memory devices. And then in 1980, now from the 1980 itself actually, the LSI era, okay, we can see called the age, okay, the new age, that is the VLSI, very large scale integration actually has evolved. And here it is greater than 20,000 components or transistors. Okay, so it is greater than 20,000, it may be the 50,000 or 1 lakh, 1 million, 10 million also the transistors. So nowadays it is 1 billion transistors are also integrated, okay, on a small chip area. Okay, on a small chip area. Now this is the ultra large scale integration techniques. After VLSI it will be ULSI. And from this VLSI technology, we see that complex microprocessor architecture, SoC means system on chip architecture. This type of heterogeneous integrated architecture, heterogeneous integration could be possible with this technology, because the number of transistors if you increase, then more number of functionalities you can increase. Okay, and if you want to increase the more number of functionalities, then you must require the more number of basic elements. Basic elements or cell is the transistors. So you have to have a good more number of transistors on a small place. Okay, but obviously this has this technology is having a great challenge also, posing some challenge. Okay, so it is not easy task to integrate all the transistors in a small place. If you have a large number of transistors, then also you are welcoming so many difficulties also. We have to look into the power issue, energy issue, noise related issue, then the cooling issue, cooling of the chip, okay, heat generation, how to handle the heat, so much heat, how to dissipate the heat. So many issues, okay, the planning, That means how you could put this number of transistors in a small place. What is your architecture? What is your layout? What is the design? So actually, this could open the door of so many new research domains and topics. Okay, to the young generation researchers. Okay, with this involvement of VLSI technology. So that's why VLSI is very popular. Okay, among us, because it is a door of so many new, actually the research topics, the topics of the study, okay, where we can concentrate, we can give our thought, okay, to design some indigenous system, some novel system, very efficient architecture, okay, very fast architecture like that. So this is the picture of Intel 4004 microprocessor. It is the first microprocessor structure. You can see it is 1971. It consisted of 1000 transistors and speed was 1 megahertz operation. At that time 1 megahertz was more than enough, but now we cannot think of 1 megahertz. 1 megahertz is very slow. Now, when you want to buy some device, first initially we actually want to know what is the speed. Is it 3 gigahertz, 4 gigahertz? Then okay. Otherwise, if it is below than 2 gigahertz, then okay. Oh, there is no speed, nothing. Speed is 0. Like our internet bandwidth. Okay. Then nowadays the bandwidth is how much? Bandwidth we prefer. 1 Gbps. Okay. Before that, there is no bandwidth. Okay, at all. Internet speed is very slow. Download speed is very slow. So now because we have to move with the new generation, the new invention, the new research community. This is the Intel Pentium 4 microprocessor, the 2002, and you see the transitions. What is the number of transistors? 42 million transistors. 42 million transistors in the year of 2002. Intel, okay, the architecture and operation 3 gigahertz operation. So in 2002. Intel has already reached the 3 gigahertz. Okay. So, but not in a single day. It took long years, many years. Okay. So now, what is VLSI?